Hurricanes batter the Gulf Coast with terrifying regularity. Katrina, Isaac, Ida. These names conjure up images of devastation. Homes demolished, neighborhoods submerged, and lives tragically lost in the battle against nature's fury. In response, a massive $3.7 billion project is underway with the aim of shielding New Orleans and its neighboring communities. Known as the West Shore Lake Pontchartrain project, this initiative promises an 18-mile-long barrier that will reshape the swampy Louisiana landscape and protect more than 60,000 residents. But engineering this protective shield is anything but easy. The project faces colossal challenges, particularly the remote marshlands and treacherous terrain that make construction incredibly complex. To meet these challenges head-on, engineers are turning to advanced computer simulations to battle test their designs against every possible storm scenario. The stakes could not be higher. This ambitious project may be the region's only hope of preventing the next hurricane from becoming another unimaginable disaster. But to fully understand the urgency, we must first explore the nature of the storms that threaten this region. Hurricanes, tropical storms, and typhoons are among Earth's most powerful natural forces. Their destructive trademarks include violent winds, relentless rainfall, tornadoes, and perhaps most terrifying of all, storm surges. A storm surge is a towering wall of seawater, pushed ashore by a hurricane's powerful winds. Imagine streets flooding in minutes, homes swallowed by water, and everything in the surge's path swept away. These surges are the most deadly and destructive element of a hurricane, and New Orleans is particularly vulnerable. The city sits in a low-lying basin, flanked by Lake Pontchartrain and the mighty Mississippi River, and protected by an intricate network of levees, floodwalls, and gates. While these defenses are vital, they are also potential points of failure, as demonstrated during Hurricane Katrina in 2005. When Katrina, a Category 3 hurricane, made landfall, storm surges exceeding 20 feet breached levees and turned neighborhoods into lakes. The result was catastrophic. Thousands of homes destroyed, lives lost, and billions of dollars in damage. Just weeks later, Hurricane Rita followed, a sobering reminder that Katrina was not an anomaly. More recently, Hurricanes Isaac and Ida have reinforced the region's ongoing vulnerability. The pattern is undeniable, and the message is clear. It's not a matter of if another storm will strike New Orleans, but when. This is why the West Shore Lake Pontchartrain Hurricane and Storm Damage Risk Reduction Project, WSLP, is so critical. Spearheaded by the U. Army Corps of Engineers, USACE, the WSLP is not just another infrastructure endeavor. It's a monumental feat of modern engineering with the promise of 100-year level risk reduction, meaning the levee system is designed to withstand a storm with a 1% chance of occurring in any given year. Building this massive levee system across 5 miles of remote marshland is no small task. It's a logistical nightmare involving access roads, environmental clearances, foundation testing, and meticulous design refinement. Engineers are using advanced modeling software, like AdCirc, to simulate a wide range of storm scenarios. These digital storms batter virtual levees, revealing potential vulnerabilities that guide design improvements before a single shovel hits the ground. The project spans the east bank of the Mississippi River, cutting through Street Charles Street, John the Baptist, and Street James parishes. The unique geography of the area, where surges can come from both Lake Pontchartrain and the Mississippi, poses an added layer of complexity. Take Contract RA 106, for instance. What looks like dense greenery on a map is actually the staging ground for a future levee. Survey teams are clearing vegetation and preparing paths through the swamp, plotting the safest and most effective routes for the barrier. Meanwhile, Contract 110 near Garyville represents the first mile of active levee construction. Here, machines clear vegetation, remove unstable soil, and level the base, laying the groundwork for a strong, reliable structure. Over at Contract 114 near Reserve, engineers are driving massive steel test piles deep into the earth. These tests assess whether the soil can bear the weight of future pump stations, critical infrastructure designed to move enormous volumes of water in seconds during a major storm. Drainage infrastructure is just as vital as the levees themselves. Simply put, if heavy rainfall gets trapped inside the levee system, flooding can occur from within. To prevent this, engineers are constructing drainage channels and pump stations that can rapidly expel water. One such drainage line, currently a series of giant pipes snaking through marshland, will soon become a lifeline during storms, moving water out of protected areas efficiently. The construction effort also required building 14 miles of land bridges and access roads strong enough to support heavy trucks loaded with materials. Once the paths are in place, sand is laid as a foundation, followed by thousands of cubic yards of clay, compacted and sculpted into the backbone of the levee. None of this is left to chance. Every material, every angle, every component is backed by years of research and rigorous simulations. However, the project has not been without controversy. Originally budgeted at $760 million, the total cost has ballooned to $3. $7 billion due to environmental concerns, additional engineering requirements, and long-term maintenance needs. Of that $1, $27 billion covers the core levee and pump infrastructure, while another $7 billion will go toward environmental mitigation and ongoing support. Critics question the rising price tag, but supporters argue that the cost of inaction is far greater. After all, how do you put a price on lives saved, homes protected, and economies preserved? When the next hurricane strikes, and it will, the 60,000 residents behind the West Shore Lake Pontchartrain levee system will have a fighting chance they didn't have before. This isn't just a wall of earth and concrete. It's a bold investment in resilience, a testament to what modern engineering and collective willpower can achieve, a shield for those living on the front lines of climate-driven storms.